So good afternoon, everyone. We are we
Good
are here
afternoon,
with the
sir.
lecture number 41 of data structures and algorithms, and we are now about to start the unit number 3, that is sorting and searching as per the RT curriculum. Is my screen is visible to you all?
Yes, sir.
So sorting and searching, third unit as per the RT syllabus. We have completed 2 units in which we have studied. Till now, we have studied about the 3 different data structures, that is stack, queue, and linked list. Okay, all of these are the kind of linear data structures. We have seen the various operations that we can perform on the data structures. Now we are coming on to the sorting and searching part. We have already started somehow the sorting and searching algorithms, as we have completed.
Sir,
Yes, yes.
sir, voice is very slow, sir.
Okay. Is it okay now? Hello, is it okay now?
No,
Okay,
sir.
sir.
No, sir.
Voice is not okay till
No,
now?
sir, it is too slow, sir.
Still, it is not okay?
Sir, volume is too low. Low volume. Sir, please lower down your mic to your mouth from your headphone.
I have increased the volume to full. Is it
सर
visible to
मुझे तो
you?
सही आ रही है.
Is it audible to all? Anyone else who has a problem? Dia, is it audible?
Yes, sir.
नो सर ऑडिबल नहीं है, आपकी आवाज कम आ रही है.
Yes, sir, बहुत low volume आ रही है. सर, आपका
You
माइक आगे कर लो थोड़ा फेस के आगे.
मेरा माइक
यस
इधर
सर,
है।
या फिर वो आपका ईयरफोन या फिर हेडफोन है वो हटा कर देखो एक बार, शायद तब भी इम्प्रूव हो.
आप अपने माइक की वॉल्यूम बढ़ाइए बच्चे एक बार. Like, if is it visible to? Is it audible to someone else properly?
Yes, sir.
Yes, sir.
So
Now it
now
is.
it's
Right now.
better.
यस सर,
Yeah,
नाउ
okay.
इट्स बेटर.
Okay, done. So we have somehow started the sorting algorithms also, sorting and searching, and we have completed searching algorithms, which are of 2 types. Can anybody tell me what is searching algorithms?
Binary, binary search.
Binary searching.
Linear search or
Linear
binary
search and
search.
binary search.
These are 2 different kinds. I am asking about the definition of searching algorithm. Searching
Sir, finding a element or a key in a given container.
and return its location. It is a complete definition. Okay, finding whether the particular element or key is in the array or a list or not, and then return, if it is there, then returns the location of that particular key. And there are 2 different kinds of searching algorithms we have studied, that are linear search and binary search. And I think we have made the program also of both of them.
Yes, sir.
And sorting.
Yes, sir.
Now coming on to the sorting part. Sorting is, what is sorting?
So to
We
arrange the array,
arrange the
Arrange,
element
either in ascending or
arranging
in descending
and
order.
descending order.
Arranging the values either in ascending or descending order of a given array or a list. And we have also done a bubble sort algorithm for sorting,
Yes, sir.
and we have made the program also.
Yes, sir.
Yes, sir. Bubble sort.
Okay, so I am starting the sorting algorithm now. In third unit, we have some sorting algorithms that we have to cover as per the view of the second midterm examinations. So let us we will start quickly, and we will try to do like more in less time. Okay, so first of all, what is sorting algorithms? So sorting is nothing but where the input is a sequence of n numbers, a1, a2, an. They are random numbers, and output will be the permutation, or we can say the reordering of all the numbers such that every number is lesser than, or like first of all we will say the lesser than, so every number is lesser than to its preceding one. Okay, like a1 is lesser than a2, a2 is lesser than a3, and a3 is lesser than a4, and so on. Or it may be vice versa also, every number must be greater than or equals to the preceding number. So in this way we are saying that the output will be either in the ascending order or the descending order. So this is what the sorting is. Why we are studying the sorting algorithms? There are many ways or various situations that we can have in our daily life, or whenever we are trying to make any softwares or programs. Some of them could be like, are all the keys distinct? It means whatever the values we are using in the given data structure. Now when I am talking about the data structure term, it means it could be an array, it could be stack, it could be queue, it could be linked list, whatever it is. Okay, so data structures, if we want that all the elements or the keys of the data structures are different or not, for that we can use the sorting algorithms. Okay, this is what we are talking about, the very large databases, not even the very small databases. Okay, so if we sort them and if we compare it, then it will become easy to identify the different keys present in the data structure. How large is the set of the keys to be ordered? Okay, like whatever the keys we have, the size also matters a lot when we are trying to ordering the algorithms. Okay, whenever we need to performance, we need a guaranteed performance. It means key, like when we want key particular thing needs to be happened. Okay, we need to improve the algorithms, we need to improve the situations, then we can use sorting algorithms also. Now whenever we want also that key, like suppose randomly ordered arrangement is required, then it is again sorting algorithms may be required. So various algorithms like are there that may be useful as per the requirements of the situations or whatever the questions given to us, or whatever the problems given to us. So there are different kinds of sorting algorithms, and some of them are this is very important now. Okay, so first of all, the internal sort. Now we are talking about some categorization of the sorting algorithms, so be careful on that point, because in interview they may be asked about the difference between these kinds of different types of algorithm actually. Okay, so internal sort first of all is the sorting algorithms in which the data to be sorted is all sorted in the computer's main memory. It means whenever we are not required some external devices to sort the things, then it is called the internal sorts. Majorly all the algorithms are internal sorting algorithms. Okay, but the opposite of that are, if suppose when the data being sorted do not fit to the main memory like RAM. Okay, suppose data is too large and we required some external memory or in order to sort them, then we can say that it could be an external sort algorithms. Okay, like the definition is, external sorting is required when the data being sorted do not fit into the main memory of the computer. It may be a RAM, and instead they must resides in the slower external memory, that is hard drive. Okay, so whenever this kind of situations are there, then we can say that it is an external sort algorithms. Okay, now next one is in place sort algorithms. In place, yes.
Sir, can you repeat the external sort because I was not understand.
External sort is a sorting algorithms when the internal memory, or we can say a primary memory, is not sufficient to sort the data, and
Okay,
and
sir.
and and like we need some external memory for sorting the algorithms. Okay,
Okay, sir.
then
Primary
next,
memory RAM.
so then yes, RAM is the primary one, and the secondary one could be the hard drive or whatever you can use. In place sort algorithm, next one is, so the amount of extra space required to sort the data is constant with the input size, that is called in place sorting algorithm. It means ki, like suppose I am talking about ki, like an n number is given to me to sort, and I required only one extra element position or size in order to sort. So it is in place sort algorithms. Sometimes we require to swap the values, and suppose 5 elements are given to me and I need some extra space to sort the values. In that case, if the sorting space is not depending, sorry, extra space is not depending upon the input size, then it is known as in place sort algorithm. You have got it? In some,
Sir, please repeat.
I'm repeating, in some sorting algorithms, we required extra space to sort the algorithm, like counting sort. We will see how. Okay, so like what we need to do, we need to place, or we need to use that particular extra memory to available list in order to sort it. Okay, and now suppose that extra memory is constant and it is not depending upon the size of the input. It means whether the size is 5 or whether the size is 500, it doesn't matter at all. Okay, but in every case I required the same amount of the memory in order to sort the algorithms, then it is called in place sorting algorithm. Is it okay? जब हमें एक एक्स्ट्रा मेमोरी की रिक्वायरमेंट होगी और वो एक्स्ट्रा मेमोरी साइज पर डिपेंडेंट नहीं होगी, input size per, then it is called in place sorting algorithm. Okay, we will see how, like in coming like lectures, in coming slides, we will see how the in place sorting actually is. Next one is stable sort. That is very important actually. Stable sort is very important. And next one, non comparison, is also very important. These two features are there that differentiate the algorithms, sorting algorithms. Stable sort is, what is stable sort? First of all, let us understand. So it may be possible when the data is given to me, it may have the duplicate values. It is possible, like the data is 1 2 1 2 3 4 5. So इसमें 1 and 1 2 repeat हुआ है, duplicate values हैं. Okay, so now पहला one कौन सा है? First one. Based on the position of the one, we will find the first one. And आउटपुट लिस्ट में जो पहला नंबर पहली पोजीशन पर है 1, it will be the first in the output list also, and on the same time the second I, that is on the third position actually in the list, input list, will be at the second position of the output list. So you are understanding it, the order of 2 ones are maintained. That is called stability feature. We will see again in the counting sort. Counting sort is a stable sort algorithm. Insertion sort is also a stable sort algorithm. Okay, stability is clear? Yes or no?
Yes,
Yes,
sir.
sir.
सर स्टेबल सॉर्ट में जो एलिमेंट सॉर्ट होगा वो उसकी पोजीशन
Like
पर डिपेंड
suppose
करेगा.
1 2 1 2 है मेरे पास sorting algorithm के लिए, मुझे sort करना है, इसका output will be 1 1 2 2. Is it okay? So this one should be this, and then second one should be this. This is called stability. It means the order of 2 ones or 2 duplicate numbers needs to be maintained. That is called stability of feature of the sorting algorithms. अब suppose कि ये वाला वन यहाँ आ जाए और ये वाला वन यहाँ आ जाए, then it is not stable sort. So the algorithm which ensures that the order also matters, maintained, then it is called stable sorting algorithm. Is it okay now?
ओके सर.
So duplication of the data is possible. Algorithm that does not change the duplicate's original ordering relative to each other is the stable feature. And the algorithm which follows this concept is called the stability sorting. Now non-comparison sorting, it means कि there will be no comparison at all. Like suppose in bubble sort में हमने क्या देखा था? We are trying to compare the elements. Yes or no? In bubble sort we have compared the elements. We have compared the first element with the next one and the second one and third one and so on. हम उसको maximum element we are trying to take at the last position by comparing the elements. So that was comparison sort algorithm actually. It means it includes comparison. But again in the case of counting sort, non-comparison sorting is there actually. We will avoid the comparison. We will do sorting without comparing the elements at all. हम compare करेंगे नहीं. Or if the sorting algorithms uses the concept of comparisons, then it is called comparison sorting, and otherwise it is called non-comparison sorting. Definitely non-comparison algorithms जो होते हैं, that will provide the that will be actually more efficient in compared to the comparison sorting algorithms, because somehow we are trying to reduce the like overall number of steps or number of we can say comparisons, so speed automatically increase ho jayegi. Okay. Parallel sorting next. Parallel sortings, whenever we are using the multiple processors, then it is called parallel processing. That is a very high level concept of the sorting algorithm. Okay. So parallel sorting, it means ki when we are using multiple processors for sorting the numbers or the different lists, then it is called parallel sorting algorithms. Adaptive sorting algorithms. Adaptive, again, it is very important. A sorting algorithm is said to be adaptive if it takes the advantages of already sorted elements in the list. Okay, like suppose I am in bubble sort also, we have seen that. Like in the first pass, we have moved the largest element at the last position. Yes or no?
Yes, sir.
Yes, sir.
In the second pass, we have moved the second largest element at the second last position, and now last two elements are sorted. So क्या हम उन two sorted elements को pass 3 में consider करेंगे?
नहीं
No,
No,
करेंगे।
sir.
sir.
नहीं करेंगे. Then if we are doing so, or if the algorithm is using this concept, then it is adaptive algorithms. Otherwise, it is non-adaptive algorithm. Okay. So you have got the things. What is adaptive? If the concept or the algorithms uses the already sorted part of the array or whatever the list is, then it is called adaptive. But if the algorithms considers every element, whether it is sorted or not sorted, then it is called non-adaptive algorithms. So you can make the bubble sort adaptive or non-adaptive. हमने
यस
यदि
सर,
loop
यस सर, बनाई
हमने
थी मैंने।
यदि हमने अडेप्टिव लाइक डेफिनेटली यदि अडेप्टिव हम यूज कर रहे हैं तो कम नंबर ऑफ स्टेप्स लगने वाले हैं, और यदि हम नॉन अडेप्टिव यूज करेंगे तो उसमें डेफिनेटली ज्यादा नंबर ऑफ स्टेप्स लगने वाले हैं. ओके, it will not visible when the algorithms data is very short or array is very short. It will be definitely visible when the data is too large. So now the different types of algorithm, sorting algorithm is okay. Internal sort, external sort, in place sort, stable, non-comparison, parallel, adaptive, and non-adaptive. Now common sorting algorithms are that we need to study: insertion, selection, bubble, counting, quick, merge, heap, radix, bucket, and many more are there also. But we have to focus on that. So we are starting with the first one, that is insertion sort. Should we start?
Yes, sir.
यस
Till now,
सर।
any doubt? Till now, any doubt? So this is insertion sort now. Insertion sort. Please, first of all, concentrate on the name of the algorithm. Like in the case
इंसर्शन,
of, case of bubble sort, I have tried to give you a clue so that you can remember the logic of the bubble sort. And that clue was the heaviest element will be at the last position. यदि हम कभी भी बबल की बात करें तो बबल हमेशा कहाँ जाता है? उठ के ऊपर चला जाता है. यस और नो? बबल कभी नीचे नहीं बैठता है. बबल ऑलवेज ट्राइज टू मूव अपवर्ड्स in the like container. Okay, so similarly here we are using that concept in bubble sort, like the element needs to move in the upward direction and it needs to be at the last position. So bubble, वहां पर हम बबल को हैवीएस्ट एलिमेंट मान लें, थोड़ा सा कॉन्ट्रडिक्शन है, लेकिन हमारे रिमेंबरिंग के लिए दैट इज व्हाट आई वांट टू गिव यू अ क्लू. So that is the concept in bubble sort we are using. We will try to find the maximum element and then we will move it to the largest or the last position. Now insertion sort, same. So insert keyword is there actually. Insertion sort is very much similar to the insertion in the array.
इंसर्शन सॉर्ट में एलिमेंट को सर एलिमेंट को इंसर्ट करने के लिए कुछ भेज दें, पहले मतलब बाद में सॉर्ट करें।
I'm not getting you what you are saying. आपकी voice clear नहीं थी. So insertion sort is very much similar to that of the insertion in the array actually. So how we insert the array element in array? First of all, can anybody tell me?
With the help of loop.
Oh,
With the help of
definitely.
for loop,
Definitely. Thank you so much for telling us this thing. With the help of for loop, we can insert. I'm asking about the logic actually.
Sir, we need
Yeah,
to
So that
get
we
the
need to know the
index.
position where we need to insert.
AI equals to 1, 2, 3. ऐसा कुछ.
Suppose this is what the value of the array already we have. Now suppose you need to insert the 7. Insert 7 after 2. आपको insert करना है 7 after 2. So what is the logic?
Then, sir, we have to
We
We
have
need to
found the
shift
address of
the
2.
rest of the elements.
Yes, we need to shift 3 to this vacant position, then 5 to this vacant position, then 4 to this vacant position, and then the position is available over there at 4, and we can insert the value 7 over there. This is how we can insert the value 7 at the in the array, insertion in the array. The same logic we are going to use in the insertion sort actually. And we can also compare this one with the playing card games. The idea of the insertion sort is similar to the idea of sorting the playing card. I think most of the students have somehow played using the playing cards. So जब भी आपको दिए जाते हैं तो हम उसको सॉर्ट करने की कोशिश करते हैं हमेशा. Yes or no?
Yes, sir.
yes,
काफी.
Yes, sir.
Yes, sir. काफी गेम खेला है ये.
तो सबसे पहले लाइक सपोज आपको इनविजिबल थे सारे कार्ड्स, सो यू हैव पिक्ड एंड यू हैव फाउंड इट इज 2, देन इट इज, आपने सबसे पहले 2 को प्लेस किया, देन 4, सपोज इट वाज देयर 4, ओके, देन 5 एंड 10 सपोज ऐसा कर चुके हैं ऑलरेडी आप, तो नाउ यू नीड टू इंसर्ट 7, सो आप 7 कहां प्लेस करेंगे? तो फर्स्ट ऑफ ऑल
After 5.
After 5.
After 5 or before 10.
So
we create a
now you
space.
need to shift the 10. Yes, we need to create the space in between 5 and 10. It means we need to shift 10 to one position ahead, and then it will be created a space, and then we will insert the 7 at that particular position. Now look at that actually. With the help of that diagram only, what we can do is we can understand the logic of insertion sort actually. Okay. So first of all, see, insertion sort may, whenever you are going to insert the new element, so the already existing element is always sorted.
Yes, sir.
Get that point. First thing is that. So insertion sort may, whenever we are going to insert the new element, the already existing array will always be sorted. होना चाहिए sorted. यदि वो sorted नहीं है तो आप insert कर ही नहीं पाओगे. Done. तो first requirement आपके insertion sort की क्या होगी कि आपका जो array है वो sorted होना चाहिए. ओके,
पहले से शॉर्ट होना चाहिए.
वेरी गुड, पहले से सॉर्ट होना चाहिए, है ना? तो अब क्या इनपुट एरे सॉर्टेड होता है आपके पास?
नहीं तो सर
No,
रैंडमली
sir.
हम
तो फिर क्या
एलिमेंट
दिक्कत
डाल
है?
देते हैं.
Sir, we can use bubble sort.
No, 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 no. We are not going to use any other sorting algorithm for this. If we have got the sorted element, sorted array, then what is the need of sorting? If you have sort the element array with the bubble sort, then what is the need of insertion sort? You have already sorted the array. So what we will do is we will come on to that point. Okay. It is very interesting thing in this actually algorithm. Okay. So first thing we need to consider that the element, whenever, please underline my word. मैं जो बोल रहा हूँ वो ध्यान से सुनना. Whenever I want to insert the new element into the array, my statement is that whenever I want to insert the new element into the array, then that array at that time must be sorted. Okay. Now again, this is the same concept. So like 12 I need to insert, to 6, 10, 4, 24 and 36 is already sorted. So first of all, I need to shift 36. I need to shift 24. Then I can insert the 12 over there. Okay. Is it okay now? That is how we can make a space for that, and then we will be able to insert the array. So क्या हम यहाँ पर कंपैरिजन कर रहे हैं? फर्स्ट ऑफ ऑल, फर्स्ट क्वेश्चन इज दैट इज इट कंपैरिजन एल्गोरिथम और नॉन कंपैरिजन बेस्ड एल्गोरिथम?
Sir, comparison.
Comparison हो रहा है.
कंपैरिजन हो रहा है. वी आर कंपेयरिंग 12 by 36, देन वी आर कंपेयरिंग 12 by 24, देन वी आर कंपेयरिंग 12 by 10. तो हमने कब तक कंपेयर किया?
जब तक इस ग्रेटर
तब तक उससे जस्ट छोटा नहीं मिल गया.
जब तक उससे जस्ट छोटा नहीं मिल गया. वेरी गुड. सो मेरे पास एक कंडीशन मिली, दैट इज अगेन, ये पॉइंट आप नोट करते रहिएगा. यू हैव टू नोट डाउन ऑल दीज इन योर नोटबुक बिकॉज दिस विल हेल्प अस टू राइट द एल्गोरिथम. तो वी आर कंपेयरिंग द इनपुट एलिमेंट टू द ऑलरेडी एग्जिस्टिंग लिस्ट विच इज सॉर्टेड, एंड वी आर ट्राइंग टू फाइंड आउट द एलिमेंट विच इज फर्स्ट एलिमेंट विच इज लेसर देन दैट एलिमेंट, बिकॉज उसके बाद ही हम उसको इंसर्ट करेंगे. Yes or no? 36 is not lesser than 12, so we will move. 24 is not lesser than 12, then we will move. 10 is lesser than 12, then we will stop. And then we will insert the element by incrementing the value of I by 1. Suppose I की value अभी 10 पर आ गई है. I पहले कहाँ था 36 पे. 36 then 24 पे आया, then I 10 पे आया. अब I को AI को हमने compare किया 12 से, key से. Then we have found कि AI is lesser than that. Then we will insert the element at what position?
AI plus 1.
Very good. AI
AI
plus 1.
plus 1.
So ये last step होगा आपके algorithm का. AI plus 1 is equals to value. ये ध्यान रखिएगा आप लोग, है ना. Now second condition. अब suppose I need to insert 4. Instead of 12 it is 4. Now what? 6, 10, 12.
Before 6.
6, 10,
Before 6.
12. हाँ. So in that case हम कहाँ तक गए? I की वैल्यू कहाँ तक गई? इंडेक्स कहाँ तक गया?
0 तक।
वेरी गुड.
0.
नहीं, इंडेक्स की वैल्यू होगी -1 एक्चुअली.
सर -1 पहले हमने
यस सर
एलिमेंट
-1 होगी वो लूप
बस
जब टर्मिनेट
इनिशियली
होगा।
आप देखो
-1
स्टार्ट करो. I की वैल्यू इनिशियली है 3, that is 36. So condition not satisfied because it is greater than that. 2, then again it is greater than 4. 1, again it is greater than 4. 0, it is 6, again greater than 4. Now it is becoming 1 lesser than that 0. It is -1, and now the loop will start hold. So it may also possible कि somehow the element that we are going to insert is the smallest one. So it will be inserted at the 0th position. Yes or no?
Yes
Yes,
sir।
sir.
So that is the another condition when the loop will get hold or stop. Okay, so दो condition हम लगाने वाले हैं loop के अंदर. One condition will be when the element is lesser than that, and when the second one will be when it becomes lesser than 0 also. It means all the elements of the array have been scanned, and now we need to insert the element. Done? Concept is okay. Again, in that case, you can see that again, if it is -1, then we need to increment the value of I. So element will be inserted at I plus 1. It is -1 plus 1, 0. So that statement will remain as it is. So now coming into that insertion sorting algorithm, it is the simple sorting algorithm which sorts the array by shifting the elements one by one, that we have already seen. Following are some of the important characteristics of that. It has one of the simplest implementation when the data is small. Please be remember that when the data is small, then it is simplest one. Otherwise, it is not efficient algorithms if we are talking about the large data list. Insertion sort is adaptive. What is adaptive? It means adaptive, you know now.
Means it is not sorting the element which are sorted.
It is not using the sorted elements
Comparison.
again.
Very good.
Taking
So,
it is
advantages,
not
taking
compare
advantages of the already sorted.
already
so can we use this dash
sorted element.
concept in this insertion sort as per the examples we have seen? क्या हम वो concept use कर रहे हैं?
Yes, sir, we are sorting first and then we
Very
are
good.
Yes sir.
So insertion sort is adaptive sort. It is okay now, है ना? Which definitely increase the efficiency of the algorithm. Okay, now it is better than the
Sir?
select. Yes.
Sir, how we are using this? क्योंकि हम तो हर एक एलिमेंट से कंपैरिजन कर ही रहे हैं.
Comparison different thing is there. I am not telling the comparative algorithm. It is definitely non-comparative algorithm. Sorry, it is definitely comparative algorithms, but I am talking about the different thing that is adaptive. Adaptiveness is if we are using if we are do not going to change the already sorted list. Okay. If
Sir,
we have some part of the algorithm, some part of the array which have been sorted already, and we are not going to change it, then it is adaptive algorithm. Just read that definition of adaptive sort. A sorting algorithm is said to be adaptive. It takes advantage of already sorted elements in the list that is to be sorted. So क्या हम already sorted elements की help ले रहे हैं या नहीं ले रहे हैं इस sorting के अंदर?
ले रहे हैं सर.
Because the first statement of the insertion sort, मेरा जो first statement था वो यही था कि we will insert the element in already sorted element. That is what the thing of adaptiveness is actually. We are taking help somehow the sorted list.
Sir, in this case, we are picking from a deck of cards, or we are just sorting after we got a particular amount of cards in our hands.
Like before insertion, do we have a sorted list or not? 6, 10, 24, 26 is sorted or not?
Yes sir, it is
Yes,
sorted.
yes, sir.
So we are using the concept of sorted, like we are using that property key. If the element is or the list is already sorted, then it will help me out to insert the new element. That is what the
Yes,
adaptive.
sir. Okay,
So
okay, okay.
वही तो
तो
adaptiveness
सर
बताती है.
हमको
इसको एक बार रीड करो
ये
आप लोग. A sorting
तो
algorithm
सर
is said
हमको
to be adaptive if it takes the advantages of already sorted elements in the list that is to be sorted. लाइक अब जैसे मैंने बबल सॉर्ट का एग्जांपल लिया था, उसमें थोड़ा डिफरेंट था. आप उसी को केवल उसी को पॉइंट मान के मत चलिए. वो दैट वाज कि इन बबल सॉर्ट व्हाट वी हैव डन इज वी हैव सपोज वी हैव at the pass number 3 and up to pass number 2 we have placed two largest element at the last two positions. So in that case, how we are helping, how we are taking the help of that sorted algorithm is we are not going to sort them again. That is how we are going to help the, we are getting the help of the sorted list. Okay, but in this case insertion sort, how we are getting the help of the sorted array is we are able to insert the element at its proper positions when we have the already sorted list. So
तो
with maybe
सर इसका
सर
मतलब
मतलब अडाप्ट
है कि हमको एरे में एलिमेंट पहले से ही सॉर्ट इंसर्ट करने पड़ेंगे, 2 के बाद 3, 3 के बाद 4.
नहीं, वो हम कोई प्रोसीजर करेंगे तो उसके अकॉर्डिंग वो सॉर्टेड ही बनता जाएगा. वो हम देखेंगे कैसे करेंगे अभी.
Sir, in this example of cards, we are picking the cards or we already have the cards in our hands and then we are inserting?
We are picking the cards from the very first. Initially,
Yes.
I don't have any card in my hand.
You are just picking one by one with your
Yes,
hand and then you
yes.
are inserting it. Okay, sir.
Randomly I am picking it. Like suppose first card is 10. I have picked one. The value of the card is 10. तो मेरे पास अभी केवल one card है, that is 10. Then suppose 36 I have picked, then 36 is there. So क्या sorted है या नहीं है ये? सबसे पहला एलिमेंट. अब उस पॉइंट पे आते हैं. चलो, जो अभी शायद बेस्ट क्वेश्चन पूछा था, कोई और पूछ रहा था. सो लेट अस कम ऑन टू दैट पॉइंट, हाउ द एलिमेंट्स विल बी सॉर्टेड अगेन. सो इनिशियली सपोज ये 5 कार्ड हैं, उल्टे पड़े हुए मेरे पास. ओके, 6, 10, 24, 36 एंड 12 उल्टे पड़े हुए हैं. अभी मेरे पास टेबल से मैंने उठाया इनको. फर्स्ट कार्ड आई हैव पिक्ड एंड द वैल्यू ऑफ दैट कार्ड इज 20. नाउ इन माय हैंड आई हैव द कार्ड लेबल 10. इज इट ओके? नाउ दिस सिंगल कार्ड इज सॉर्टेड और नॉट?
So it is sorted with
Sorted.
Yes, sir.
Sorted,
It is
sir. It is sorted.
It is sorted. So the another tagline of the insertion sort is single element is always sorted. So whenever you have started with the array and you have picked the first element of that array, that element will be, we will consider that that element is already sorted. Now I have a sorted list or not? I have a sorted list of single element. That's it with me. Now I'll pick the
Yes,
second
sir.
card. Now I have picked the second card, suppose, and now second card is 36. So now you will put or you will place the second card to the right of 10. Yes or no?
Yes, sir.
So now you have two elements, and are they sorted or not?
Sorted.
Yes, sir.
Sir, sorted.
ऑलरेडी सॉर्टेड.
In this way, we will get the sorted list one by one. Initially, whether it is given to us sorted or not, it doesn't matter at all. We will start with the very first element of the list, and then we will place the second elements at its position, and then third element and fourth element, and so on. In this way, so in this way, actually, we are going to take the help of sorted property of the elements. That is what the adaptiveness is. Is it okay now?
सर मतलब हमें sorted elements की help से sorting करनी है.
That's
That
it.
is adaptiveness.
In bubble sort, it is something different. Like somehow it is little bit different. Is there? Like once we have sorted some elements, we are not going to touch them.
We already
So-
have the cards in bubble sort if we think.
सर उसमें sorting की help ऐसे हुई क्योंकि हमारे number of steps reduce हो गए.
इसमें भी reduce होंगे definitely. ये suppose definitely reduce. हाँ, मतलब you can say that. Very good. And now इसमें भी that is same we are doing this. Suppose I am not having the sorted list. Suppose 6, 10, 24, 36 random order में होते और 12 को आपको place करना होता, तो क्या आपको पता होता 12 को कहाँ place करना है?
नहीं सर, यहाँ पे sorting की help ऐसे हुई क्योंकि हमें sorted array already मिला था
Already मिल
और
गया, है ना?
comparison में आसान होती है.
That is what the adaptiveness is. Suppose somehow I am getting the help from the sorted elements of the array, then it is called the adaptiveness. But in like opposite, suppose कि in contrast of that, suppose I am saying कि I am अभी मेरे पास 6, 10, 12 और 36 sorted हैं, but again in order to insert the 12, अब मुझे सबको shuffle करना पड़ रहा है. ठीक है, सॉर्टेडनेस कहीं यूज ही नहीं हुई मेरी। पहले मैं 10 और 12 और 36 को कंपेयर कर रहा हूँ सपोज, तो 12 के बाद आया 36, ठीक है, 12 लास्ट में इंसर्ट हो गया, अब 12 और 36 कंपेयर होकर के स्वैप हो गए, तो 12 और 36 हो गए, सो ये गड़बड़ हो गई। फिर हमने 12 और 24 को कंपेयर किया, तो फिर 12 इधर आया, एंड सो ऑन। तो हम कंपैरिजन नहीं कर रहे हैं, तो वो हम हेल्प ली नहीं हमने सॉर्टिंग की। तो नाउ इज इट ओके, क्लियर है अब सब? कैन वी मूव अहेड नाउ?
Yes, sir. It is
Now it
clear.
is now next is its space complexity is also less. Like the bubble sorting algorithm, insertion sort also requires a single additional memory in order to sort the elements. Okay, so it is again a constant space required. So ये किस तरह की in place sort हुई है? You have got the thing, in place sort. The amount of the extra space required to sort the data is constant without the input size. So here what we have required a single additional memory. Why single additional memory required? Can anybody tell me in that case?
We are
So we
applying
have
the
to shift
operation on a
na.
single element.
Yes, we are trying to shift ना actually. Suppose I am
Only
having
we
5.
shifted the element.
हाँ, तो 1 अब
To
हम
shift, we require a space.
very good, and that space is only one additional memory at a time,
Yes, sir.
and it does not
Yes,
depend
sir.
upon the input size. Input size से कोई मतलब ही नहीं है इसका.
No, sir.
So that is what the in-place sorting is. So most of the sorting like most of the terms that we have learned इस sorting algorithm में clear होंगी आपके. Yes or no?
Yes, sir.
Yes, sir.
Last one is it is again a stable sort. It means कि as it does not change the relative order of the elements with the equal keys. So इसमें वो order maintain रहता है जो input order था आपका two common elements का, two duplicate elements का sorry, तो वो order will be maintained in the output list also. That is why it is also an stable sorting algorithm. So आपसे क्वेश्चन पूछा जाता है वाइवा में, like name any sorting algorithm which is stable sort. Any two algorithm which is stable sort. It could be insertion sort. It could be
Sir, how we will prove that it is obeying the stable sort algorithm?
Stable sort algorithm. Yes, when we will see the algorithms one by one, step by step, then you will be able to justify it also. Now I am coming on to the like example at all. So let us finish that first theoretical part. In an insertion sort, the first element in the array is considered as sorted. That is what the highlight of that particular slide. Okay, even if it is an unsorted array, जो मैंने अभी अब डिस्कस किया था, first element will always be sorted. Single element will always be sorted. In an insertion sort, each element in the array is checked with the previous element, resulting in the growing sorted output list. With each iteration, the sorting algorithm removes one element at a time and finds the appropriate location within the sorted array and insert the element at that particular location. And that iteration continues until the whole list is sorted. That is the basic logic of the insertion sort. Is it okay now? ये सारे points जो हम already discuss कर चुके हैं, that is what the points are. And based on that, what we can say that two main taglines for the insertion sorts are: insert, as the name suggested, insert the element in already sorted array. Do I need to justify this thing now? Say yes or no at least.
No, sir.
No.
And next one is single element is always sorted. Again, do I need to justify it?
No, sir.
So this is what, तो ये this is the insertion sort. तो अब insertion sort का लॉजिक हमेशा ध्यान रहेगा आपको. तो इन दो रेड लाइन से आप जस्टिफाई कर सकते हो कि व्हाट इज इंसर्शन सॉर्ट. इन दो रेड लाइन से यू कैन रिमेंबर दैट व्हाट इज द लॉजिक ऑफ द इंसर्शन सॉर्ट. So what we need to do, we need to insert the element in already sorted array, and first element will always be sorted, that we will consider. Okay, this is with a single slide I have tried to explain the concept, and after that I will take a proper example also. Please understand that thing. 5 1 6 4 2 4 3 is suppose is the list of array. What we have done is first fifth element is already sorted, we have considered
Sorted.
it. And then so now tell me, from the loop start with
I
loop
equals to
must,
1.
so loop will start from the second element. Just keep that thing in your mind. Loop will also start with the second
I
element,
equal to
because we will consider that first element is already sorted. So sorting, we will start sorting with the second element. So हमारा जो एल्गोरिथम बनेगा वो आप ध्यान रखिएगा, हम हमेशा लूप जो स्टार्ट करने वाले हैं वो सेकंड एलिमेंट से करेंगे. So now first fifth element is already sorted, so we will place 1 at its position. So definitely 1 and 5, this is sorted now. Yes or no? And this red arrow shows the position of 1.
Yes, sir.
Then 6 needs to be inserted in the sorted array. So 1 and 5 is sorted array, 6 needs to be inserted. So 1, 5, 6 is the sorted array after the final this. Okay. Then 2 needs to be inserted in the sorted array, that is 1, 5, 6. So 2 will be after 2 or after 1, sorry. So we will shift the 2 at the second position, and the list will be a 1, 2, 5 and 6. And then 1, 2, 4, 5, 6 is sorted array, and we will try to insert the third element. So 1, 2, 3, 3 will be at the third position. Is it okay now? Is it
yes,
okay?
sir.
Yes, sir.
Any doubt till now? Now look at the example in detail actually. Okay, this is the list 927175143. So we start the dividing array. Acha, one more thing I want to justify at that point. In this, with the help of that particular slide, you can understand that we try to divide the array into 2 parts. In every step, we will try to divide the array into 2 parts. You have got it. One part is sorted and one part is not non-sorted part. Is it clear?
Yes, sir.
है ना, like मेरे जो wherever I have put the mark with the black ink, like that every step we have divided the array into 2 parts, and one first part is sorted and second part is unsorted part. So in this,
Sir,
yes,
so why are we having a previously defined array? Can't we just randomly choose the numbers and put in an array?
this is what only this is the randomly chosen numbers, and we have put the numbers into the array 5, 1, 6, 2, 4, 3.
So
That's it.
initially it was 5, then we are choosing 1 and then 6 and
It is randomly entered by the user. That's it. I have not taken from directly from my side. It is, you just assume it that the user is entering that number at random positions. Okay. So 9, 2 item to the position. Okay. You see that 9 is already sorted section. ये sorted element है हमारे पास. Then we need to point the 2, like find the position of the 2. So it will be swapped now. Okay. Here how is it being compared with 9? The comparison is there. So 2 and 9 will be placed now. Now 2 and 9 are sorted position. Okay. So now 7 needs to be inserted. So 2, 7 and 9. So अब compare करो आप कि हम कब तक compare कर रहे हैं. First of all we are comparing the 9. Sorry, 9 को हमने कब तक compare किया. यहाँ से आप check करो. 7 is there. 7 को we have compared with 9. Okay. 9 needs to be shifted. 9 needs to be shifted. Then 7 will be compared with 2. So do we need to shift 2?
No, sir.
So comparison stops. So this is the condition of loop now. 2, 7 will be placed over there. 2, 7, 9 is sorted. Now 5. So 5 needs to compare first of all with 9. 9 needs to shift. 5 needs to compare with 7. 7 needs to shift. Then with 2. Then it needs not to be shift and 5 will be at its position. So the concept is okay. Now the second condition 1.
सर ये तो डबल शॉट में भी कर रहे थे.
नहीं, ऐसा कुछ नहीं कर रहे थे हम. 1. So 1 will be compared with 9, then 7, then 5 and then 2. Again 2 will be shifted or not?
Yes.
yes, sir.
Sir, it will be
Shifted.
Yes, sir, shifted.
So this is the second case, second condition that we need to put in the while condition. Okay, and 1 will be placed at that particular position. Similarly 4 will be compared. Similarly 3 will be compared. Similarly 6 will be compared. In this way we will get the sorted elements. So what is the way of working actually? You can see that first of all we have select the element. Okay, then we have compared the element with the previous elements, with some of the previous elements, and parallelly we are shifting the elements, and then we have insert the element. So that is the way we are doing in the insertion sort. Is it clear to all? Select, compare, shift, and insert. Is it okay? This is another example I have taken of that, where we are trying to select, then we are
Yes, sir.
to compare, then we are trying to shift, then we are trying to insert. Okay, so select, compare, shift, and insert. Any doubt till now?
No, sir.
Okay, so please hold a minute. Please wait for a minute. Okay. Yes, any doubt now? Can we move on to the algorithm now? Is it visible to you all?
Yes, sir.
Yes, sir.
Okay. Okay. So this is the step-by-step procedure for insertion sort. If it is the first element, it is always sorted, and we need to return one. Okay. Pick the next element, compare the elements with all the elements in the sorted sublist, then shift all the elements in the sorted sublist that is greater than the value to be sorted. Now insert the value, and these all needs to be repeated until the list is sorted. So is there any doubt now? Select, compare, shift, and insert. Select. Second step, we are selecting, we are picking up the element, then we are comparing, then we are shifting, and then we are inserting. Is it okay? Now we are coming into the algorithm part. Algorithm, it means a programming or function part that we need to use in our array. Now look at very carefully on that. This is a function of insertion sort that you can directly use in your program also. So should I share this one or not? Should I discuss this one or not?
No, sir.
No. Good. So I suppose that you will write on your own.
Yes, sir.
Yes, sir.
Good. Very good. So I am skipping that thing. So now any doubt in that? I have tried to explain the conditions also that we need to put into the while loop, or why I am saying the while loop, because we are trying to put two conditions. So it is always better to use while loop when we have two or more conditions with us. Okay, instead of for loop. So we can use while loop in that. Trying to start the loop from the second positions. That is the clues what I am giving to you while you will try to write an algorithm to by your program to. Try to start with the second element of the array, because first element we have already assumed that it is sorted. In first step you can see that. Okay, so we will start picking from the second element. दो conditions लगेंगी till first the element will be lesser than or equal to that element, or we have reached at the zero position, zero index. And at last, what we need to do, we need to, like parallelly in that loop, what we need to do, we need to shift the elements. उस loop में आप क्या कर रहे होंगे, आप compare करके shift कर रहे होंगे. So till the condition is true in the loop, you need to shift the elements. So statement will be ai plus 1 equals to ai. तो ये आप shifting के लिए कर रहे होंगे. And जब आप loop से बाहर आएंगे तो you definitely one condition will get false. Either the element is lesser than, or we have reached as the 0th index. So in that case, what we need to do, we need to increment the value of I by 1 and insert the value. So I plus 1 equals to item. That's it. ये algorithm part होगा आपका लिखने के लिए. So is it okay now? Or if it is okay, then I need to move on to the second algorithm, that is selection sort. Tell me fast. Yes, students. Should I move to the next one?
Clear.
Everyone else? I am continuing this lecture also. So if you want a break, then
Sir,
we
break
can,
दे दो sir.
then we can have. Otherwise, we can continue for that next class.
Sir, break दे दो sir 5-10 मिनट का सर, क्योंकि सर पिछली क्लास भी सर 12-10 तक चली थी.